Okay, I hear the recording in progress, so we're recording now. So let me do my introductory remarks, and then if you want to ask me stuff, you can go ahead and ask or put it in the chat. So let's go ahead and share the screen. All right, so I'll say what I normally say. This is all repetition, but it's just to make sure to catch everybody. All right, so tomorrow is our second test, Friday the 24th. You must join the Zoom session. All these other days are optional. Some of you come all the time, some of you don't, some of you attend half the time. You all have to show up for the test. I will take attendance, so if I get an exam from you, but I don't see you in the Zoom class, I will not accept your exam. Obviously, how do I know that it was really you that took it, right? So you must join the class, have your camera on, the true background, no Golden Gate Bridge, no outer space or something like that. And keep yourself muted. If you have any questions during the test, put them in the chat. So I'll send by Canvas announcements the exam around 8:01, 8:02, something like that. Then you join the Zoom session. I will close the Zoom at 9 o'clock. And then you have until 9:05 to click, take pictures on your cell phone, or if you have a scanner, I prefer scan because scan usually comes out better. And then you have until 9:30 to submit the homework. Although once class is over today, I'll start accepting homework. If you want to just submit your homework and say, get it over with, then you're allowed to do that. Okay, you're allowed one cheat sheet, so one formula sheet, 8.5 by 11, both sides. Put anything that you want, any formula, sample problems, that's allowed. And you can have a calculator, but nothing else. So no other people, no computer, no internet, no other notes and so forth beyond what we said. And have your first and last name on your Zoom as on my row sheet. Don't have me guess who you are. Don't just give me your first name. Don't just give me your last name. I want your first and last name as it appears on my row sheet, so I don't have to guess who you are for the exam. And now that you've seen one exam, you kind of know what it's all about. Okay, and so again, there's that 70% homework requirement. So you turn in 7.1 through 7.8, all of this. I need at least 70%, but I do a huge percentage. Sometimes I end up doing literally 70% or even more. So the amount that you actually have to do is a lot less than just copy what we did in class and go from there. And of course, you can see there's a few changes, but I've marked them all off here. Okay, so if you don't give me at least 70% of the homework, I do not grade your exam. It will count as a 0, right? So I do have that homework requirement that's there. Okay, so this is exam 2 out of 5. We have test 3 here, test 4 here, test 5 here. You already know the dates for them, right? Tentatively coming up, but we'll worry about it when we get to it. Right now, we're focusing on exam number 2 that we have right here. Okay. And what else? I think I've covered everything. During the exam, if you need to step out, go to the bathroom, get a drink of water, that's fine. Let me know if that happens. So I don't assume you just disappeared and got the answers from a friend or something like that. Okay. All right, so I think that's it. The rest of the hour is yours. Ask me stuff. So if you want to either unmute yourself and ask me questions or put them in the chat, you can do that right now. I'll get my sketch paper ready. But I wasn't going to start doing new stuff, but if there isn't a whole lot of questions, then we'll just go ahead and do stuff. By the way, I did send out a video on some questions that somebody had in 7.3. So since I've already covered that, you can just look at the video for that. I assume would be the best way to do that. Okay, so let me go ahead and check the chat for some problems. That's all right. I do see some problems now. 7.2, 37 and 39. 7.4, 15. 7.8, 23, 29. Okay. And all right, that'll probably keep me busy for a little while. Oops, stopped the share accidentally. Let's go ahead and go back in. All right, let's take a look. 7.2. Okay. 1.237. Pi over 4 to pi over 2. Cotangent to the fifth, cosecant q. D phi. Okay, so let me write this as pi over 4, pi over 2. Let me break out a cosecant cotangent. So I'll borrow one from each of these. Cotangent to the fourth, phi, cosecant squared phi. This is the Greek letter phi or phi. Sometimes it's used for empty set. And cosecant phi, cotangent phi, d phi. Let's see, a derivative of cosecant is almost cosecant cotangent. So I want all of this to only say cosecant. So this is already cosecant. Let me do this. So integral from pi over 4 to pi over 2 of cosecant, cosecant squared phi minus 1. So we have this identity, 1 plus cotangent squared phi is cosecant squared phi from trig. Okay, if you need to put that in your cheat sheet, you may. So that means cotangent squared is cosecant squared minus 1. Okay, so this is cotangent squared squared, cosecant squared phi, cosecant phi, cotangent phi, d phi. Okay, then we substitute. U equals cosecant phi, du is negative cosecant phi, cotangent phi, d phi, which means I need a -1 here and a -1 here. Okay, and then let's see. We have phi equals pi over 4. U is cosecant pi over 4. Cosecant is the reciprocal of the sine, 1 over sine pi over 4, which is 1 over radical 2 over 2, which is 2 over radical 2, which is radical 2. And then at pi over 2, u equals pi over 2. Sorry, phi equals pi over 2. U equals cosecant pi over 2, which is 1 over sine of pi over 2, which is 1 over 1, which is 1. Okay, so my new integral is going to go from radical 2 to 1. So negative integral radical 2 to 1. So this is now u squared minus 1 squared times cosecant squared, which is u squared. And then -1 cosecant theta cotangent theta d theta is du. Switch this around, 1 radical 2. U to the fourth minus 2u squared plus 1 u squared du, which is 1 radical 2 u to the sixth minus 2u to the fourth plus u squared du. So u to the seventh over 7 minus 2u to the fifth over 5 plus u cubed over 3. From 1 to radical 2. And I think at this stage, I'll just say etc. in the interest of time. Okay, but you would just plug in, but that's the basic idea behind it. 39 integral of cosecant. Okay, we actually never did this. The proof of this is just like the proof of the secant. Cosecant x plus cotangent x, cosecant x plus cotangent x. like that. If you look at how the text did integral of the secant, it was similar. So cosecant squared x plus cotangent squared x plus, right, cotangent x, cosecant x, sorry, over cosecant x, cotangent x dx. This is cotangent x, cosecant x. And there should be a plus here. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. So it works out. So u equals cosecant x plus cotangent x. Du is negative cosecant x cotangent x minus cosecant squared x dx, which is the same thing as a numerator, except it needs a -1. So -1, -1. So I is integral of the opposite of that plus that, which is all this stuff. So I have a negative du over u, so negative ln absolute u plus c, or negative ln absolute cosecant x plus cotangent x plus c. Okay. That is that. 7.415. -1 to 0. X cubed minus 4x plus 1. X squared minus 3x plus 2. Okay, let's see. X cubed plus 0x squared minus 4x plus 1. There's no x squared term, so you have to put it in as a coefficient of 0. X squared minus 3x plus 2. X squared into x cubed is x. Then multiply x cubed minus 3x squared plus 2x. X cubed minus 3x squared plus 2x. Okay, subtract. That cancels out. 3x squared minus 6x plus 1. X squared into 3x squared is a plus 3. 3x squared minus 9x plus 6. Subtract. That cancels out. 3x minus 5 plus 3x minus 5 over x squared minus 3x plus 2. So this one I have to do partial fractions. 3x minus 5 over x minus 1, x minus 2 equals a over plus b over x minus 1, x minus 2. X minus 2, x minus 2, x minus 1, x minus 1, x minus 1, x minus 2, ax plus bx, so a plus bx plus negative 2a minus b. Really kind of funny, that should be a 1. Almost looks like a 2. Ax plus bx minus 2a minus b. Okay, so that means a plus b has to be 3. Negative 2a minus b has to be negative 5. So a plus b equals 3. Negative 2a minus b equals negative 5. Add them up. Negative a equals negative 2, which means a equals 2. B equals 1. All right, so the original integral becomes integral from negative 0 to 1 of x plus 3. That's already there. And now this stuff is a 2 over x minus 1 plus 1 over x minus 2 dx. Okay, so that's x squared over 2 plus 3x plus 2 natural log absolute value of x minus 1 plus ln absolute x minus 2 from negative 1 to 0. And I'll just say etc. After that. Hmm, 7.823. I'll show you this again so you get a chance to look at that. I realize I'm going fast, but again, on a day like this, I'm aiming for quantity more than quality. I'll cover it again. 7.823. Negative infinity is 0. Z over z to the 4th plus 4 dz. The graph would probably look something like that. So here's b, and then you pull b toward negative infinity. So limit b approaches negative infinity, and you go from b to 0, z over z squared plus 4 dz. Derivative of z squared is 2z. So I need a 2 and a 1/2. That 1/2 will come all the way out. So t equals z squared. dt equals 2z dz. Z equals b. T equals b squared. Z equals 0. T equals 0. So the I has a 1/2 in front. Limit b approaches negative infinity. Integral, instead of b to 0, I'm now going from b squared to 0. So 2z dz is now dt over t squared plus 4. Okay, I'm supposed to have a 1, not a 4, so I'll divide top and bottom by 4, divide by 4, divide by 4. Take the 1/4 out. So 1/2 times 1/4. Limit b approaches negative infinity. B squared to 0. dt over 1 plus t over 2 quantity squared. U equals t over 2 or half t. Du equals 1/2 dt. So inside you need a half. Outside you need a 2. Very conveniently, these cancel out. T equals b squared. U equals 1/2 b squared. T equals 0. U equals 0. So now I have 1/4. Limit b approaches negative infinity. integral from 1/2 b squared to 0. 1/2 dt is now my du over 1 plus u squared. That's my inverse tangent. (1/2 b squared to 0 equals 1/4 limit b approaches negative infinity. Inverse tangent of 0 is 0 minus inverse tangent of 1/2 b squared. So when b goes to negative infinity, this goes to positive infinity. Okay, that approaches pi over 2. So let's see, 1/4 pi over 2. So it looks like I'm going to get pi over 8 out of this. Okay. So unless I goof somewhere, that's what I think I have. Oops. I'm going to go from -2 to 14 dx over radical x plus 2. Okay, so I'm not allowed to plug in -2, but I can plug in a number close to it. So limit b approaches -2 from the right. If you think of the graph of this, can't do that, but I can move a little bit over. So b is here, 14 is over here somewhere. B to 14, x plus 2 to the -1/2. Limit b approaches -2 from the right. This would be x here. So x plus 2 to the 1/2 divided by 1/2. From b to 14. Take out the 2. Limit b approaches -2 from the right. That means square root, right? Square root of x plus 2. 14. 2 times limit b approaches -2 from the right. Okay, plug in 14. I get the square root of 16, which is 4. Minus radical b plus 2. And now b approaches -2 from the right. -1.9999, that approaches 0. So I have 2 times 4. So it looks like the final answer is 8. Okay, so I think I've caught up with that batch. Let me check the chat for more. 7.425, 7.1, 5, 13, 15, 7.2, 13, 15, 25. What time is it? 7.4, 25, 7.1, 5, 13, 15, 7.2. Okay, so I think I've caught up. 7.425. Okay, and yes, it is fair to assume you only have an hour, so I cannot ask you the longest questions that you've had, except maybe just a subset of it because it will take too long to do one of them. 7.425, that might actually fall into that category. 4x over x cubed plus x squared plus x plus 1 dx. Yeah, so This one, I'm pretty sure I will not ask you to do the whole thing. It's too long, but I might just have you set up without determining the coefficients. So that means just go like this. Let's see, I can factor out an x squared plus 1 times x plus 1, which is 4x over x plus 1, x squared plus 1. Right, so to actually finish the whole thing would be quite a bit, but you should definitely be able to set this up. X plus 1, x squared plus 1. And let's see, this is linear, therefore A. This is irreducible quadratic, therefore bx plus c. Okay, so that's as much as I'm going to do for this. I mean, the rest of the problem is a nice problem, but it'll take 20 minutes to do this one problem if you can do it quickly, right? So that's as much of that one as I'm going to do for now. 7.1, number 5. T e to negative 3t. Okay, polynomial with exponential, let u be the polynomial. So u equals t, dv equals e to the negative 3t dt. Differentiate this side, integrate this side, which means I do backwards of the chain rule for derivatives. Let's see, for the chain rule for derivatives, I multiply by negative 3, so I'm going to integrate negative 1/3. Okay, so I is uv, negative 1/3 t e to negative 3t, minus the integral of v du, negative 1/3 e to negative 3t dt. So 2 negatives here make a positive. Negative 1/3 t e to negative 3t plus 1/3. Integral of e to the negative 3t, well, I just did it. Negative 1/3 e to negative 3t plus c, and etc. The last step is to change that to negative 1/9. In the interest of time, I won't bother with the 1/9, but you should keep doing that in the test, of course. Okay, 13 t cosine squared t. I've got to get another sheet of paper. T cosecant squared t dt. U equals t, dv equals cosecant squared t dt. Du equals dt, v equals negative cotangent t. So I is uv, negative t cotangent t minus the integral of v du. So there's a negative 1 here. Cotangent t dt. That's a double negative, that makes it positive. Plus, okay, integral of cotangent. You can put that in your cheat sheet, or it's cosine over sine. So it's ln absolute sine t plus c. You could, if you forget, you can just remember that's cosine divided by sine and just do a u substitution. You know, quick double check, this would be 1 over sine times cosine, so that gives me that. Okay, so that takes care of that one. See, 15 ln x squared. Tx. Now we don't really have any choice except let this be u. U equals ln x squared, dv equals dx, which means v is x. Derivative of this is 2 ln x times the derivative one, which is 1 over x dx. So I is uv x ln x squared minus the integral of v du. This times this, or this times this, the x's would cancel out, right? So that times that, x cancels out, I got a 2. So 2 integral of ln x dx. You can write down the formula for integral of ln x, if you wish. It's 2x ln x minus x plus c. 7.213. Radical cosine theta cubed. Okay, so this has an odd exponent. Sine squared theta, sine theta, d theta. So therefore, I want everything behind my finger to only involve cosine. That's easy. That's already cosine. That's sine squared, which is 1 minus cosine squared. So radical cosine theta, 1 minus cosine squared theta, sine theta, d theta. Let's see here. U equals cosine theta. Du is negative sine theta d theta. I need a -1 and a -1. So I is negative integral of radical u, 1 minus u squared. -1 sine theta d theta is du. So 1 times radical u is radical u. U to the half minus u to the squared is u to the 5 halves. Du, distribute the negative. Turn this around, u to the 5 halves minus u to the 1 half. Du, I could go up. That's u to the 7 halves over 7 halves. That looks like u to the 3 halves over 3 halves. So u to the 7 halves divided by 7 halves minus u to the 3 halves divided by 3 halves. And just change u back to cosine theta. So 2/7 cosine theta to the 7 halves minus 2/3 cosine theta 3 halves plus c. Let's see, how much time do we have? Maybe 15 minutes. 15. Cotangent cosine squared. Cotangent. Oh. Cotangent times cosine squared. Cosine should be x, sorry. 0 x's. Cotangent is cosine over sine. So cosine x over sine x times cosine squared x dx. So that's cosine cubed. Well, let me write it like this. Sine x, 1 minus sine squared x. So I want stuff with only sine and then cosine x dx. This is cosine squared, right? Okay, so u equals sine x. Du is cosine x dx. So my integral becomes integral of 1 minus u squared over u du, which is 1 over u minus u du. So natural log absolute u minus u squared over 2 plus c. Change u back to sine x. So ln absolute value of sine x minus 1/2 sine squared x plus c. Okay. 25. Change of the 4th secant to the 6th. Okay, derivative of the tangent is secant squared. So let me separate out secant squared. Okay, so that means I want all of this to only involve tangent. This already only has tangent. How do I change that? Tangent to the fourth x, secant squared x squared, secant squared x dx. And I know secant squared is 1 plus tangent squared. So that pretty much does it. Tangent to the fourth x, 1 plus tangent squared x squared, secant squared x dx. Okay, u equals tan x, du equals secant squared x dx. So this is my du. That's u to the fourth, 1 plus u squared squared, u to the fourth, 1 plus u squared squared du, u to the fourth, 1 plus 2u squared plus u to the fourth du, distribute, 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 u to the fourth plus 2u to the sixth plus u to the eighth. I'll write that above since I ran out of space. U to the fourth plus 2u to the sixth plus u to the eighth du. Okay, u to the fifth over 5, 2u to the seventh over 7, u to the eighth over 9, plus a constant. And then just change u back. What was u tangent? 1/5 tangent to the fifth x plus 2/7 tangent to the seventh of x. Get this thing in focus here. Plus 1/9 tangent to the 9 of x plus c. Okay, that takes care of that. Let me check the chat again. Okay, what I did for number 25 is what we should expect for the exam regarding these types of problems. Yes, you should know how to do this type of problem, separate this out. I mean, if you want, you can even put this as an example problem on your cheat sheet for this. Okay. If you want to play the game, you know, oh, he's probably not going to give anything too long. You're right. I know you only have an hour, actually technically less than an hour. Okay. So some of the problems were really long. It's good for homework or a quiz, but to have you do the whole thing in 1 hour is not reasonable. So I might just have you do a subset of it, as the case may be. Okay, let's see, 10 more minutes. I think I've caught up for the last 25 for 7.4. Let's see what you mean by that. Yeah, 7.425. Yeah, this 20. Yeah, definitely I would not have you do the whole thing. But that might fall in the category of something like this, right? Set up, but do not determine the values of the coefficients, right? So just tell me A over or BX plus C over, etc. Okay, for that kind of problem. So I'll go ahead and disclose to you, this is definitely under the too long category. I would not have you do this problem in its entirety. Okay, and you can expect about 10 questions. Okay, I realize many of you didn't finish last time. We'll see how it goes this time with the problems, but yeah, take it as it is. Okay, I think I've caught up with the question list. Again, it's hard for me to check the chat and do the problems at the same time. So if I missed your question, go ahead and put it back in the chat once more. Otherwise, I think I've caught up. Okay, so any more? I know, let me stop the share. It's probably easier for me to see if I take this off. And yeah, rather than looking through the chat list, that's going to take me too long. So again, if you think I missed your question from the chat, go ahead and type it in again. It's probably easier that way. Otherwise, I think I've caught up. And at this stage of the game, I don't think I'm going to start the next chapter. So I think we're okay time-wise and waiting for Monday to get started with all that. Okay, so anybody wants to ask me a question, please? Otherwise, I think we're done. And if I miss your question again, put it back in the chat. Otherwise, that's it. All right, I don't see or hear anything else, so I guess that'll do it. So you may start turning in the homework now, if you wish, but otherwise you have up until half an hour after the test tomorrow, which would be what, 9:30? Okay, so exam ends at 9. You have until 9:05 to submit the test and 9:30 to submit your homework. All right. Okay, so that'll do it, folks. So get your formula sheet together, get your cheat sheet ready, and get your homework ready. And we'll see you for the test tomorrow. Okay. All right. Bye, everybody. See you next time.
Thank you.
Well, take care.
Okay. Bye.